So where we covered last time had to do with async tasks as respect to the different patterns that they implement and with respect to the way in which there were different kinds of black box and white box elements in the async task framework and the async task class. What we're going to do today is I'm going to talk in more detail about how to actually use async tasks to implement an actual application. And this application is something you can get here at my website. It's called Async Task Interrupted. And so let's first kind of talk about what this program does, and then I'll walk through the source code, which will give you a chance to see how you program an async task. So as has often been the case up to this point, we're going to use something to program a GCD application, which figures out the greatest common divisor of two numbers, which, as I'm sure you know by this point, is the largest positive integer that divides two integers without a remainder. And the other idea here is that the user can cancel async task computations at any point along the way. Something else that you can do with this particular implementation, as we'll see, is you can also rotate the application, and that won't affect the computations that are taking place in the background. It's designed using a clever Android feature called onRetainInstance, which we'll talk about when we look at the code. So here's just a quick summary of what we're about to look at from a design point of view. And this, of course, will illustrate both the black box and the white box features of async task. So there's a superclass called lifecycle logging activity that we use just to make it clear what's going on when you debug your program. It makes it easier to see in the logcat what's happening. There's a MainActivity class, which is what interacts with a user, interpreting mouse clicks or button presses, rather, with the touch screen. And this will be used to start and stop the async tasks in order to do the computations. There's also this really interesting class. I kind of refer to it as a shim class called async task related state. And this is basically the object. This is the class that's used to make an object that will store state, which will include the async task instances and the thread pool executor and so on and so forth, that are actually passed between instances of MainActivity as you rotate the phone. So as the phone rotates, this object is passed around so you don't have to worry about starting and stopping the computations that are running. And then the real workhorse thing here, the class that does all the work, the part that's most relevant for the assignment that's coming up here, is the GCD async task. And this is a really nice illustration of async task in all of its full-blown glory, with all of its hook methods that are used to do various things before and after the computations run in the background. OK, so that's basically the end of the overview of the design. Let us now go and take a look. So here's the project. We'll take a look at two parts of it. Hopefully it's big enough to see in the back. So the GCD async task is the main workhorse of the program. As you can see, it extends async task, and it fills in the three template parameters that you need to have in order to instantiate an async task. So the first parameter, which is an integer here, is the type that's passed to do in background. So when you execute something, it gets passed to do in background. The second parameter is something that's passed to onProgress update when you call publish progress. We'll take a look at that. And then the third parameter, which is a Boolean, is a value that's returned from do in background, and it's passed as the parameter to onPostExecute. So these are just the ways you can parameterize the types that are used for the various parts of the framework. This is a nice example of combining inheritance in order to be able to override those hook methods with the use of generics in order to be able to give types that are used by various methods. OK, so that's the basic structure of this thing. We then have a main activity, which we need so that we can call back and get to the outside part. We have a random number generator, which is used to generate the numbers. We keep track of the instance of the async task. This is used primarily for debugging purposes. The constructor assigns these things. There's a setActivity method. So when the rotation occurs, we just give it a new activity. Here's the GCD computation. This is the one that will compute the GCD, just a classic Euclid's algorithm. Now we get to some interesting methods. These are the hook methods. These are the ones that are called back at various points by the underlying framework. So the onPreExecute method, as hopefully you recall, that's the one that gets called back before the background thread starts to execute to do the computations that run in the background. And in this case, we just print out the async task as a debugging message. We print out its number so we can tell what's about to happen. Here is do in background. This is the method that gets run in the background, and this is the one that does the actual computations. As you can see here, it's passed in the max number of iterations to do for the testing. What it's going to do is it's going to go ahead and have a loop that runs for those iterations. It'll generate 2 random numbers, check to see if it's canceled or not, and if it is canceled, it'll shut down. If it's not canceled, it'll check whether or not it should print out a message. We run these things typically for tens of millions of iterations, so we don't want to print out every time we go through the loop. So we do it every so often, every million times, so we'll do a print or so. And when it's time to print, you can see, remember, this is running in the background thread. So what we do is we go ahead and we call publish progress, and that will then send, in this case, a string from the background thread to the user interface thread where it will be published. And we'll see where it gets published, how it gets published in a second. So what we're going to do here is we're just going to print out some debugging information or some status information to say we're in do in background. Actually, it should say in do in background. I can type. And it says what thread it's in and so on and so forth. Now, here's the last thing that happens in this method. So remember, when do in background is finished, when it's done running, it's going to go ahead and return something. And so what it does in this case, it's going to return true or false. If it returns false, that means it was not the last task. If it returns true, it was the last task. And so what it's going to do here is it's going to go ahead and decrement the task count by 1. So it's going to atomically decrement the count and then read the value of the decremented count. And if the result is less than or equal to 0, it was the last task. And so it's going to use that to indicate that the thing should do something in response to that. The onPostExecute method should do something in response. So that's all this stuff gets done in the background. This is how we go from the background to the foreground. We publish progress. And here is the publish progress status hook method. This is called onProgressUpdate. And as you can see here, it simply prints out the message. And this will take place in the user interface thread. So that's a good way to get information from the background thread to the user interface thread. And then here is the onPostExecute method. This is what gets called back when we're done running that loop. And as you can see here, it prints out that it's finished. And if this was indeed the last task, if this was the last task to finish running, then we're going to tell the activity we're done, and it'll go ahead and shut down in a graceful way. So that's a clever little trick to do something when the last thread goes away, or the last background thread goes away. This is what gets called back if everything goes according to plan. If everything did not go according to plan, in other words, if we got canceled, then in that case, the onCanceled hook method gets called, and that basically says we are finishing up after being canceled, in which case we're done. Any questions about any of that stuff? So that should give you some ideas of how to structure your use of async tasks in the programming assignment, although obviously your programming assignment is somewhat different in terms of the actual logic that you do. Here is the place where we create those async tasks. This is the MainActivity program. There's a lot of stuff in here. I won't go through it all. The most important one is a method called start computations. That's what's going to happen when you click the button and tell the program to start running. And so what we're going to do here is we're going to get a count of the number of iterations that we want to run. That was passed in by the user. And assuming they didn't give us a negative or 0 count, here's what we do. We're going to have a count of the number of async tasks. Let's say, for sake of argument, that there are 4 of them. So what we're going to do in this case is we're going to create a range of integers from 1 to async task count, which let's assume is 4. From 1 to 4, we're going to create a range of integers from 1 to 4. And this is inclusive because it's a so-called closed range. So a closed range means we go from the beginning up to the end. If you just said range, it would go from the beginning to 1 less than the end. So what we end up with is numbers 1, 2, 3, 4, let's say. And for each of those numbers, we're going to map that number to an object, and the object is going to be something called new GCD async task. That was the thing we just looked at. And we pass in the activity, which is this, so that the async task knows how to get back to the main activity to print stuff. We give it the ID, which in this case is 1, 2, 3, 4, and we give it a new random number generator to use to generate random numbers. So this will create a new GCD async task object. That is then passed to the next operation in the stream, in the pipeline, and that comes in as an async task. And so what we're going to do here is we're going to say, hey, async task, go ahead and execute on this executor. And this executor, we'll take a look in a second and see how the executor is defined. But basically, the executor is going to be the place where we're going to be doing the computation. It'll be a thread pool that's going to run in the background. And we're going to go ahead and pass in the count, the number of iterations that we want to have the thing run. So that's going to go ahead and execute that. So that's going to start running in the background. And then the last thing we do here is we collect all these things into a list, and that list can then be used later to shut things down. Okay, so that's just kind of how we use a stream to get things up and running. And notice we don't have any loops. We use the range closed mechanism to do that. The only other thing here that's really interesting from the point of view of your programming assignment is probably up here in the constructor. So you can see, here it is. So here's the constructor for this thing called async task related state. So async task related state is this class that contains state we want to live across configuration changes. In other words, when you rotate your Android phone. And the things we want to survive that rotation would be the executor service, the count of the number of tasks, the thread factory, and the task list. So those things get initialized here in the constructor. We make the task count 0. We make our thread factory, so it'll basically give back a unique value with a unique name each time. And then the last thing we do here, and this is similar though not identical to what you need to do for your programming assignment, this is where we're going to create the thread pool executor. Now this particular thread pool executor is really just a fixed thread pool executor. So I could have used the executor's new fixed thread pool factory method to create this, but I just wrote it out more verbosely to show how it works. So we're going to give it the default task count and the max task count, which in this case are the same. Let's say that that's 4. We're going to have no timeout, so because we're not creating any new threads dynamically, there's no need to time them out. We then create a linked blocking queue, so that says if there's more than m task count or s max task count number of async tasks, they'll get queued up in a linked list that will be of an infinite length. And then we're going to give it a thread factory. The thread factory is what's going to be used to make the actual thread. So that's how we're making the executor. Any questions about that? Now, obviously, for your assignment, you have to do something slightly differently because you're making a cached thread pool executor, but similar idea, similar syntax, just different values. The way this works is that this async task-related state is actually going to be bundled away, and there's a couple of methods that Android provides. One's called getLastNonConfiguration Instance, which is quite a mouthful. And if this gives you back a null value, it indicates it's the first time the program's been created, or the activity's been created. And if that's the case, we make ourselves an instance of async task-related state. Otherwise, if it's not the first time, it'll give back the value. And that value is the value that is going to be returned by this hook method. So onRetain onConfiguration instance returns the MAsyncTask related state object. And so we use this as a very clever trick in order to make sure that things get stored and restored properly when things are running. Okay, any questions about that? So that should give you a good idea of how to do portions of the program. Yeah, Joe. Oh, great question. So you're referring to this. Yeah, this is this is a weird Java-ism. So remember in Java, there's two different types of types. There are primitive types like int and long and double with a lowercase d and a lowercase l and a lowercase I. And then there's also all the other so-called reference types, which are things you define, like GCD AsyncTask or whatever, right? Those are the classes that are defined. Stack, queue, hash map, those are all reference types. So because there's two type systems in Java, if you want to work with the primitive types, you have to do somewhat different things than if you want to work with types that are reference types. So in this case, we're creating an int stream of integers. So these are actually sort of built-in types. And because of that, because of this two-type system thing, map to obj is taking something that's an integer, and it wants to create an object from it. And so we have to use map to obj here so that it'll understand that what it's going to return here is now an object, no longer a primitive type. And that's, again, the consequence of the fact that Java has sort of two type systems that are not fully integrated in a completely transparent and invisible way, which is frustrating to some extent, but that's just the way it goes. The good news is if you just use map, if we were to type map here instead of map to obj, we would get some bizarre error. It would say something like this. You'd be like, what the heck? And if you look really closely, it says, bad return type in lambda expression, GCD AsyncTask cannot be converted to int. And that's because it's trying to work with it as a primitive type, not as a reference type. So the right thing to do is do map to obj. Having said that, that's rather obscure. So you just have to remember it. But don't blame me. You can blame James Gosling for that one. Yeah. Great question. So the question here is, how does AsyncTask work? And I'll answer that in just a second. Any other questions about the example? OK, so let us